NVIDIA just made one of its most important robotics moves yet, and it was not a new robot. The company is putting its latest humanoid robotics model and teleoperation tools into Hugging Face's LeRobot ecosystem. Developers can collect demonstrations, train a robot policy, and deploy it through a more standardized workflow. That sounds like NVIDIA is giving away part of its advantage. But the real strategy may be the opposite. Make robotics easier for everyone to build, then become the platform underneath the entire industry. The question is whether this creates another CUDA-like advantage for NVIDIA or gives customers and competitors the tools they need to escape its control. Welcome to Future Signal. Here is what happened, why it matters, and what investors should watch next. In announcements published July 6th and 7th, NVIDIA and Hugging Face confirmed that Isaac GR00T 1.7 and Isaac Teleop are available through LeRobot. GR00T 1.7 is a vision language action model. In simple terms, it combines visual information, language instructions, and robot actions. A person can tell a robot what to do, the model can interpret what the robot sees, and the system can generate the actions needed to complete the task. NVIDIA describes GR00T 1.7 as an open, commercially usable model released under the Apache 2.0 license. That distinction matters. This is not merely a research demonstration locked behind a corporate interface. Developers can use and adapt it commercially under a permissive license. Isaac Teleop addresses another major bottleneck: training data. A developer can guide a robot using a virtual reality controller or a leader arm, record useful demonstrations, turn those demonstrations into a dataset, fine-tune a policy, and then deploy it to a real robot. Hugging Face's example uses an affordable SO-101 robot arm performing a practical tabletop task. The point is not that one small arm changes the global economy. The point is that the workflow becomes understandable and repeatable. Demonstrate, collect, train, evaluate, and deploy. LeRobot version 0.6 also adds more models, world model policies, reward model tools, faster data loading, and a more standardized deployment command. Robotics development is beginning to look less like a collection of isolated laboratory projects and more like an ecosystem. Generative AI accelerated partly because developers gained access to shared models, shared frameworks, large datasets, and cloud computing. They did not need to design a new chip or build a new training framework every time they wanted to create an application. Robotics is still more fragmented. The hardware varies, sensors vary, motor systems vary, training data is expensive. A policy that works in simulation may fail when lighting changes, an object moves, or a gripper encounters unexpected friction. And a mistake in a chatbot is annoying, while a mistake by a heavy machine can damage equipment or hurt someone. This is why impressive demonstrations do not automatically become reliable products. A robot must perceive the world, understand a task, plan movement, control its body, and recover when reality does not match the training environment. Open models do not solve all of that, but standardized tools can reduce duplicated work. If developers can compare models in the same framework, collect compatible datasets, and move from training to deployment with fewer custom steps, more teams can experiment and improve the shared ecosystem. That is the opportunity NVIDIA is pursuing. NVIDIA's greatest advantage in AI was never only the GPU, it was the software ecosystem around the GPU. CUDA gave developers a common way to use NVIDIA hardware for accelerated computing. Over time, the tools, libraries, documentation, and trained workforce made switching away from NVIDIA more difficult, even when competing hardware existed. Robotics could follow a similar pattern. NVIDIA can open important models and workflows because it sells many layers underneath and around them. Large-scale training can use NVIDIA Data Center GPUs. Simulation can run through Isaac Sim and Omniverse. Deployment can use Jetson Edge computers. Autonomous systems can use NVIDIA's software libraries, reference designs, and developer tools. If an open robotics ecosystem creates 10 times more developers and 100 times more experiments, NVIDIA does not need to own every robot company. It needs enough of those companies to train, simulate, or deploy on NVIDIA infrastructure. This is similar to selling the roads, tools, and power systems for an emerging city rather than trying to own every building. The latest release also gives NVIDIA something strategically valuable: distribution. Hugging Face is already a familiar destination for AI developers. Putting GR00T directly inside LeRobot lowers the distance between someone experimenting with AI software and someone experimenting with a physical machine. The bullish interpretation is that NVIDIA is trying to become the default development platform for robotics before the market reaches mass adoption. But there is a second interpretation. Open ecosystems can grow markets, but they can also reduce control. If models and datasets become portable, developers may eventually run them on competing hardware. And NVIDIA's largest customers are already spending billions to avoid permanent dependence on a single supplier. Meta is a useful example. Meta says it already deploys hundreds of thousands of its own MTIA accelerators for inference workloads across content and advertising systems. It plans 4 new MTIA generations over 2 years, with chips designed for ranking, recommendations, and generative AI inference. Meta is also working with Broadcom on multiple generations of custom accelerators and with ARM on a new class of data center CPUs. At the same time, Meta continues buying hardware from NVIDIA, AMD, and other suppliers. This is not necessarily a plan to replace NVIDIA everywhere. Training the largest models and operating billions of daily inferences are different workloads. A general-purpose GPU may be valuable for fast-changing research, while a custom chip can be more efficient for a stable workload repeated at enormous scale. The important business signal is that NVIDIA's largest customers want a portfolio. They want the flexibility to use NVIDIA where it performs best and their own silicon where specialization reduces cost. That creates the central tension in NVIDIA's strategy. Opening robotics can increase demand for NVIDIA's platform. But the more valuable and standardized the market becomes, the more incentive customers have to build alternatives underneath it. So how do we know whether NVIDIA's robotics strategy is actually working? First, watch developer adoption. Downloads and demonstrations are interesting, but repeat usage matters more. Are teams collecting datasets, fine-tuning policies, and deploying them on real machines? Second, watch commercial deployments. Factory pilots and robot demonstrations must become recurring production workloads. The important milestone is not a robot completing one impressive task. It is a robot completing a useful task reliably enough to justify its cost. Third, watch the hardware mix. Does growth in robotics increase demand for Jetson, simulation, and data center training, or do open models become portable enough that competing accelerators capture more of the value? Fourth, watch customer concentration. NVIDIA benefits enormously from large cloud and technology companies, but those same customers have the capital and motivation to design alternatives. Meta's MTIA program is evidence of that pressure, not proof that NVIDIA has already lost the business. And finally, keep the scale in perspective. NVIDIA reported $604 million in quarterly automotive and robotics revenue for its fourth quarter of fiscal 2026. That is a real business, but still small compared with NVIDIA's data center operation. Robotics is a strategic option today, not yet the main financial engine. The most important robotics company may not be the company with the most human-looking machine. It may be the company that gives thousands of developers a common way to collect data, train policies, test them safely, and deploy them across different machines. NVIDIA is betting that opening more of the development layer will expand the market around the infrastructure it controls. Meta and other hyperscalers are betting that custom hardware can keep any one supplier from controlling too much of their economics. That is why this week's announcement matters. The robotics race is becoming a platform race. Do you think opening the robotics ecosystem strengthens NVIDIA or creates the competitors that eventually weaken it? Tell us in the comments. If you want weekly analysis of AI infrastructure, robotics, and the companies building the next technology stack, like the video, subscribe to Future Signal, and share it with someone following the AI market. This is news and analysis, not financial advice. Thanks for watching.